Right now, as you read this, every galaxy beyond our local neighborhood is accelerating away from us. Not drifting, accelerating. Something is pushing against gravity itself, tearing the fabric of space apart at an ever-increasing rate. We call this force dark energy, and it makes up 68% of everything that exists. We have no idea what it is. We've never directly detected it. We can't reproduce it in labs, but we can see what it's doing to the universe, and what we see is terrifying in its implications. The universe isn't just expanding like scientists thought for decades. It's being ripped apart by an invisible force that grows stronger as space itself grows larger. And the more space that gets created, the more dark energy appears to fill it, creating a feedback loop that will eventually tear apart everything, including atoms themselves. In 1998, two teams of astronomers were trying to measure how much the universe's expansion was slowing down. Everyone knew it had to be slowing. Gravity pulls everything together, so the Big Bang's initial explosion should gradually lose steam, like a ball thrown upward, eventually falling back down. The teams used Type 1a supernovae as cosmic yardsticks. These exploding stars are remarkably consistent, always reaching the same peak brightness, which means you can calculate their distance by measuring how dim they appear from Earth. The astronomers found distant supernovae and measured their light. Then they compared that to how fast those galaxies were moving away, based on redshift, the stretching of light waves as space expands. The results made no sense. The distant supernovae were dimmer than expected, meaning they were farther away than they should be if expansion was slowing down. The universe wasn't decelerating, it was speeding up. Gravity wasn't winning, something was overpowering it. Imagine you're on a raft in the ocean, and another raft is floating a kilometer away. Normal expansion would be like a current carrying both rafts apart at a steady speed. Maybe gravity between the rafts slows that speed over time. Dark energy is different. It's as if new ocean is constantly being created between the rafts, and the rate of creation increases as more ocean exists. The distance between rafts doesn't just grow, the speed of growth accelerates. Every cubic meter of space contains a tiny amount of dark energy, like an intrinsic property of space itself. As the universe expands and creates more space, it creates more dark energy. This new dark energy pushes space to expand faster, creating even more space, which contains even more dark energy. The feedback loop has been running for billions of years, and it's getting stronger. Right now, dark energy is winning against gravity on cosmic scales. Gravity still holds together galaxies and galaxy clusters, because they're dense enough to resist. But in the vast voids between galaxy clusters, dark energy dominates completely, stretching space faster than gravity can pull it back. Scientists have proposed several explanations, and none of them are satisfying. The leading candidate is vacuum energy, also called the cosmological constant. Quantum mechanics tells us that empty space isn't actually empty. Virtual particles constantly pop into existence and annihilate each other in tiny fractions of a second. This quantum fizzing should create energy that pushes space apart. When physicists calculate how much vacuum energy should exist, they get a number that's 10 to the power of 120 times larger than what we observe. That's not a small error. That's the worst prediction in the history of physics, off by a factor with 120 zeros. So either our calculations are catastrophically wrong, or something is cancelling out almost all the vacuum energy, leaving just a tiny remainder that we call dark energy. Another idea is quintessence, a dynamic energy field that pervades space and changes over time. Unlike the cosmological constant, which stays constant, quintessence could vary in strength, potentially explaining why dark energy seems to have become dominant only in the recent cosmic era, about 5 billion years ago. Or maybe we're completely wrong about gravity. Perhaps Einstein's equations break down at cosmic scales. And what we interpret as dark energy is actually a sign that gravity behaves differently than we thought when applied to the entire universe. You might think scientists are just making up invisible energy to explain observations they don't understand. But dark energy shows up in multiple independent measurements that all point to the same conclusion. First, the supernovae observations that started everything. Second, the cosmic microwave background, the afterglow of the Big Bang. This ancient light contains patterns that reveal the geometry of the universe. The measurements show the universe is flat, meaning parallel lines stay parallel forever. For the universe to be flat, with the amount of matter we observe, there must be additional energy filling space, and the amount matches dark energy perfectly. Third, large-scale structure surveys that map millions of galaxies show how matter clumps together over cosmic time. Computer simulations can only reproduce these patterns if dark energy exists and has been counteracting gravity for billions of years. Fourth, baryon acoustic oscillations. Ripples in the distribution of galaxies that formed from sound waves in the early universe. These ripples give us another distance measurement tool, and they confirm the universe's accelerating expansion. Every independent method points to the same weird conclusion. Dark energy's dominance leads to a lonely future. Right now, we exist in a brief golden age where we can still see other galaxies and study cosmic history. As expansion accelerates, distant galaxies will move away from us faster than light can travel through expanding space. Their light will never reach us. In about 100 billion years, every galaxy beyond our local group will have disappeared beyond the cosmic horizon. Future civilizations in the Milky Way would observe a universe that appears to contain only their own galaxy, surrounded by endless darkness. They would have no evidence of the Big Bang, no distant galaxies to study, no way to discover cosmic expansion. They would think they lived in a static, eternal island universe. And the acceleration continues. In trillions of years, dark energy might grow strong enough to overcome gravity at smaller scales. Galaxy clusters would dissolve. Then individual galaxies. Then solar systems. Eventually, in what's called the Big Rip scenario, dark energy could grow powerful enough to tear apart planets, then molecules, then atoms themselves. Space would expand so violently that nothing could hold together against it. The universe would end not in fire or ice, but in cosmic disintegration. Dark energy represents the biggest hole in our understanding of reality. We have theories that describe how particles and forces work at quantum scales. We have Einstein's relativity explaining gravity and space-time at cosmic scales. But we can't reconcile them. And dark energy is where that failure becomes obvious. We're essentially saying that 68% of the universe is made of something we can't explain with our best physics. Either we're missing something fundamental about how reality works, or we're seeing evidence that our current theories are incomplete approximations of a deeper truth we haven't discovered yet. Several experiments are trying to measure dark energy's properties more precisely. The Dark Energy Survey maps hundreds of millions of galaxies. The Euclid Space Telescope will measure cosmic expansion history with unprecedented accuracy. The Vera Rubin Observatory will catalogue billions of galaxies and track how cosmic structure evolves. These observations won't tell us what dark energy is, but they'll constrain what it could be, ruling out theories that don't match the data. The answer might come from particle physics, finding new quantum fields that fill space, or from quantum gravity theories that unite Einstein's equations with quantum mechanics, or from somewhere we haven't thought to look. You are living in a universe where the dominant force is something science cannot explain. Every second, space expands, dark energy pushes harder, and distant galaxies slip further beyond our reach. This isn't science fiction. This is the reality revealed by decades of careful observation and measurement. We exist in a brief cosmic moment when intelligent beings can still observe their universe's history and structure. In the deep future, that window will close. But right now, we're here. Conscious matter, trying to understand the forces that will ultimately determine its fate. Dark energy reminds us that the universe is stranger than we imagined, and that our current understanding, no matter how sophisticated, remains incomplete. The universe is being torn apart by an invisible force, accelerating toward an increasingly empty future. And we get to witness it happening. We get to measure it, study it, and wonder what it means. That's both humbling and extraordinary. We don't know what dark energy is, but we know it's there, shaping the cosmos at the largest scales. And somewhere in that mystery lies a deeper truth about reality waiting to be discovered.